Hey everybody, I was just wanted to make a video on doing some of the examples that we're going over in class about, doing transformations and, figuring out the parent function and trying to come up with a graph based off of those transformations. So I'm just going to go through a couple of the problems in example 3 from the notes, and you guys can follow along, and hopefully that'll help you, complete the problems for your homework. Okay, so the first one is -3 divided by x minus 2 minus 1. Okay, so I know that my parent function here is 1 over x. Okay, and what I'm going to do is just for this example, I'm going to draw what 1 over x looks like. Okay, so it has a branch down here, and it also has another branch up here. Okay, so the reason that you're not allowed to use 0, x equals 0, is because there's a vertical asymptote there. Okay, that's where the function is undefined. Okay, and then I also actually have another asymptote here at y equals 0. All right, that's a horizontal asymptote. So because I can't be x equals 0, I'm also never going to be y equals 0. So that's why you kind of see both the horizontal and vertical asymptote there. So when we're doing transformations of 1 over x, it's really important to figure out where your asymptotes go. I talked about with you guys figuring out a specific point to kind of shift around on the graph for every one of your parent functions, and the asymptotes are going to be the ones that we're going to use for 1 over x. Okay, so the next thing I want to do is I want to put it into standard form. So I see that I have a -3 on top. So you have to remember that originally this function started as 1 over x. Okay, and the reason that now it has -3 on the top is because 1 over x is now being multiplied by -3. All right, so you can think of it like -3 times 1 over x gives you that -3 over x. Okay, so what I'm going to do is I'm going to move that -3, I'm going to put it off to the left side, because now I can know that I have a reflection Now I know I have a reflection over the x-axis. I have a vertical stretch by 3. Okay, I'm going to move this graph right 2 and then down 1. Okay. All right, so what I'm going to do now is I'm going to draw my axis. So like I told you guys that the vertical stretches and horizontal stretches and stuff like that don't really show up that much. So as long as you guys can identify them, that's pretty good for me. Down 1. Okay. So if I'm going to move my graph right 2, all right, that means that I'm going to be moving my vertical asymptote also right 2. Okay. So instead of having it at x equals 0, now I'm going to have my asymptote at x equals 2. Okay, so anytime you shift a rational function, the left or right, the asymptote is going to move as well. Okay, and then because I'm going to move my graph down 1, that means that I'm also going to move my horizontal asymptote down 1 as well. Okay, so I have a horizontal asymptote there at -1. Okay. Now really the last thing that I need to figure out is where do I exactly need to put these two branches. Now because of the reflection, okay, if you look at the original graph, right, I have one of the branches is in the third quadrant, and then the other one is in the first quadrant. Okay, so that's a typical 1 over x. Now because of the reflection, that's just going to, both of those branches are going to flip. So now I'm going to have one in the second quadrant and the other one is going to be in the fourth quadrant. Okay. So what I want to do is I want to figure out exactly where I'm going to cross the y-axis. So I'm going to plug in 0. Now when I do that, I get 3 over 2 minus 1, which is 1/2. Okay, which is right about here. All right, so all I'm going to do is I'm just going to follow my asymptotes and make sure I go through my intercept. All right, so as you can see, that's pretty much what f of x is going to look like. You have the reflection, you have the shift to the right, and then you have a shift down 1 as well. Okay, so if you guys want to check your work, you're more than welcome to, plug that into Desmos. Okay, so the domain for this graph, right? I can use everything but the vertical asymptote. So everything from negative infinity to 2, union with 2 to infinity. And then the range is I can use everything but the horizontal asymptote. So that's negative infinity to 1, and then 1 to infinity. All right? So that's, just take your time when you're doing the 1 over x's, and you should be okay. Okay, so we already did letter B in class. I think you guys should pretty much get that at this point. Next one I'm going to do is letter C. So negative x plus 3 squared minus 4. All right, so this one's already in standard form for me. So I have a reflection over the x. I'm going to move it right 3 and down 4. Okay. All right, so because my parent function is a x squared, right, my graph should look like a quadratic. All right, and we're going to use the vertex to kind of move around. So let's see, label my graph. Okay, so my vertex originally starts at 0, 0, but because I'm going to move it right 3 and then down 4, it's now going to go to 3. Oh, I'm sorry. I'm messing up here. Sorry about that. So that's actually left 3. My mistake. Down 4. Okay, so let's figure this out. So left 3 and then down 4. Go about there. Okay, so that is negative 3, negative 4. All right, I'm going to draw my quadratic. Looks like that. And again, it's always nice to have another point on there. So I'm going to do the y-intercept again. So when I plug in 0 in for x, I get negative 9 minus 4, which is negative 13. Okay, which is going to be somewhere, obviously down below my screen. Okay, so the domain for this one, any quadratic is always all real numbers. And then the range is negative infinity, and then up to where my vertex is, which is negative 4. Okay. Okay, let's see here. All right, letter D here. I'm not really sure if we did this one in class or not, but I'm just going to go over it just again. So again, I want to put this into standard form. Okay, so I have the cube root of negative 6x plus 5, and then 3 minus 1 will put me at plus 2. All right, and again, anytime you have a number being multiplied to the x term on the inside, you want to make sure that you factor that out. So if I factor out the negative 6, that's going to leave me with x minus 5 over 6. Because when I multiply those through, the two 6's will cancel, and I'd still be left with that 5 originally. Okay, so the negative on the inside is now a reflection over the y-axis. All right, we have a horizontal shrink by 1/6. I'm going to move this right 5/6, and then I'm going to move it up 2. Okay. So again, you guys might not be too familiar with the cube root of x, because that's our parent function here. Again, the point that you want to use here is right here at the origin. Okay, the graph kind of comes up like this, and then it changes concavity right there at x equals 0. Looks kind of like that. All right, so that's the point that we're going to use. To kind of move around here. Okay. All right, now, so the first one says it's a reflection over the y-axis, okay? So as I move from left to right on my parent function, right, my graph is actually increasing as I go from the left side to the right side, okay? Now, when I flipped it over the y-axis, it's actually going to become the opposite, so I'm going to actually decrease as I move from the left side to the right side. So I'm going to draw that right here, like that. Okay, so that's going to be our kind of our basic shape that we start with here. Again, and what I'm going to do is I'm going to use 0, 0 to kind of move around. Okay, so I'm going to draw my graph. Okay, so I need to move my origin point right 5/6 and up 2. Okay, so 5/6 is pretty close to 1, and then I'm going to move it up 2, which will put me at right here. Okay. All right, so all you have to do now is just kind of finish the graph. And again, you want to make sure that you're drawing the y-axis reflection, so it's going to decrease as you move from left to right. Okay, so that's your basic shape there for that cube root function. All right, so we'll say that the domain here is again -infinity to infinity, and the range is also the same. All right, and that's going to be the same for all cube root functions. The domain and the range aren't going to change based off of your transformations. Okay, and the last one here is an absolute value function. Okay, so our parent is absolute value. Okay, so there's a little trick with this one that I'm going to show you in a minute once we simplify it a little bit. Okay, so again, just put it in the standard form. All right, so I have the absolute value of -x. Well, I'm sorry, -12x. We'll do that. -12x. And then I have 2 minus 7, which would be put me at -5. And then I have the +6 there at the back. Okay. So like I told you guys, you wanna make sure that you factor out any number that is being multiplied with your x term. Okay. So half of 5, or 1/2 times something gives me 5, which is going to be 10. Okay. So what you want to do here, right, is because it's an absolute value, right, you have the negative on the inside, which is a reflection over the y-axis, right, because it's on the inside. But what I want to do actually is I want to try and get rid of that. Okay. So anytime you have something that's being multiplied inside an absolute value, you can actually make that 2 absolute values. Okay. So what I can do is I can make this -1/2 times the absolute value of x plus 10 plus 6. Okay. So what I just wrote there is the same thing as the line above it, but now what I can do is when I simplify it now, the absolute value of negative a half actually just becomes positive a half. Okay, and that's actually what I'm going to draw here for my graph. All right. Now the reason that me getting rid of the negative actually isn't that important here, because when this is an absolute value function and it's even. It's an even function. Okay, so it's symmetric to the y-axis. Okay, so when you flip that over the y-axis, you actually don't see the reflection at all. So me getting rid of the negative isn't really going to affect my picture really that much at all. Okay. Okay, so now I have a vertical stretch, or shrink, excuse me, vertical shrink by 1/2. I'm going to move this left 10, and then I'm going to move it up 6. Okay? All right, so let's see here. Okay, so if I'm going to move, again, use your vertex here to kind of move it around. So I'm going to move it left 10. So that's going to be -2, 4, -6, -8, -10. Let me extend that a little bit. All right, and then I'm going to move it up 6. So that's going to be 2, 4, 6. All right, and let's move these guys out of the way. Okay, so now my vertex, right, is going to be at -10, +6, which goes about here. All right, and then you just want to make sure it looks like an absolute value. Looking like that, okay? Now, something about an absolute value is that whatever number I have on the outside here, that's actually the slope of the two lines that create your absolute value function, okay? So this slope here is 1/2, and then this one is just the opposite here, which is -1/2. Okay, so anytime you have an absolute value function with a coefficient in front, that coefficient is the slope of the two lines. Okay, so my domain, all real numbers, because it's an absolute value, and then the range goes from my vertex, which is 6, to infinity. All right. So make sure you guys are just you keep practicing these, and keep checking your work on Desmos. Make sure you're getting the right graphs based off of what transformations you have. Any questions? Feel free to come see me.